You need to watch this video, the video that will play after now. I laughed when I watched it. But you know, sometimes the joke can be on us. So I might be telling the truth and you think it's a joke. Alright, so watch this video.
Genotype AC.
Dissolve! Like AC air conditioner. There's AC.
Yeah, there's AC. It's a new genotype.
I don't understand. So AC help me now. People should sorry. Well, let me.
AC is just like SC. So when you say
SA.
SC.
There's SC too.
Yes, Lekon Big Brother was SC.
Funny people.
You can check.
I know AA. I know AS. I know SS. Where AC and SC come from? What and what will match together to get SC?
It's just like SS, AS, SS, you born SC, SS, AS, SS, you born SS. So it's just like, you know, like doctor will say you can come and check your. Like,
so what and what we have to marry to get?
AS, SS can marry and born SC.
Jesus, my brain one broke.
It's just like when doctors say come and check about yourself before you give birth, but they were in that period that they can give birth to a survivor kid. This city is just like SAS, but it's just like they are better off.
Yeah, like the immune is more stronger.
So don't teach me this one for school. I've been asleep that day.
No, it's just a new genotype.
It's just new.
Did you get a good laugh like I did? There's no hemoglobin C, right? Oh, okay, so let's talk about it. So people generally talk about genotype. You know, what's your genotype? Your genotype is your genetic makeup that determines your characteristics, your height, your skin color, your hair type, things like that. But genotype is an umbrella term. But what we're really talking about is hemoglobin genotype. Hemoglobin genotype is what determines the type of hemoglobin in your red blood cell. The hemoglobin is the one that carries oxygen in red blood cells to different parts of your body. Did we get that right? Okay, so let's start from there. There are different types of this hemoglobin, and it will determine the oxygen carrying capacity of the hemoglobin and the shape. There are so many types, but there are common ones that we all know. Hemoglobin A, hemoglobin S. You are familiar with those ones, right? Hemoglobin A is in quotes, the normal hemoglobin. Hemoglobin A is the normal hemoglobin, all right? And it has a high affinity for oxygen. So it helps seamless carrying of oxygen in the red blood cells. And it allows for the round shape of red cells. Unlike the hemoglobin S that has less oxygen affinity and causes the cell to sickle. All right. So these ones are the common ones we know, but there are other types of hemoglobin genotypes, like hemoglobin C. Yes, there's hemoglobin C. Hemoglobin S, hemoglobin C, hemoglobin E, and hemoglobin D. These are rare forms of hemoglobin. They are caused by changes, alterations, what we call mutations in the encoding. Don't let me confuse us. In the blueprint that encodes for that hemoglobin. So, if something is supposed to be a particular sequence, there's now substitution in the amino acid that encodes for the hemoglobin. Is what leads to the alterations that you see in hemoglobin S, hemoglobin C, hemoglobin D, hemoglobin E. All right. Now there's hemoglobin F. Yes. Have you heard of that one before? There's hemoglobin F, and you usually find that one in babies when they are in utero, when they are inside their mothers, and shortly after birth, maybe up to 6 months after birth. And that one has a very high affinity for oxygen. Babies need that hemoglobin when they are inside their mothers and shortly after birth. But after a few months, they don't need it anymore. Okay, so it goes away. And that's why you may not recognize early that a child has sickle cell disease, because of that hemoglobin F that is present up to maybe like 6 months after birth. Okay, so you need 2 of the hemoglobin genotypes. So you have A can combine with A. So 2, those are normal hemoglobins, A combining with A, and we have AA. You can have A combining with S to form AS. That's sickle cell trait. All right. You can have A combining with C, which is another abnormal hemoglobin, to form AC. So that guy was right. AC exists. Okay. You can have 2 abnormal hemoglobins coming together to form. Okay, so you can have S combining with S to form SS, which is sickle cell anemia. You can have S combining with C to form sickle cell disease. Okay, you can also have S combining with other forms of hemoglobin, the rarer ones that I mentioned, whether ED or whatever. So you can have abnormal hemoglobins coming together. So what's peculiar about the C hemoglobin? The C hemoglobin usually doesn't present as severe as you find S hemoglobin in terms of sickle cell disease. So if you have someone who is SC, the hemoglobin S combining with C, usually you may not even know that they have sickle cell disease. They may be chubby, and all of that, but that doesn't mean it doesn't present with its own challenges. You may be wondering, why do we have these abnormal hemoglobins? Well, there are theories that I've talked about how the hemoglobin S came about as a result of mutation arising from in mosquito endemic environments. So it's an adaptation to malaria. That's because, and you'll notice that people generally say that if you have malaria all the time, you have malaria all the time. Are you AA? Yeah. So because of the plasmodium, which causes malaria, they have affinity for hemoglobin A genotype. So because of repeated bite of mosquitoes, there was now an adaptation that led to the mutation you find in hemoglobin S gene, leading to hemoglobin S hemoglobin, leading to S hemoglobin. Well, those are theories about how hemoglobin S came to be. Today, my focus is not on AS, marrying AS or whatever, but I hope you have learned something about the different types of hemoglobin so that you won't be laughing from the point of ignorance. All right, Dr. Dami here. If you've gained something, please click like, share, comment, engage, ask questions, and we will be willing to answer your questions. This is Dr. Dami Medic TV.